Hi, welcome back. We're going to try question 3 next. Okay, we're given some information about A and B and their probabilities. We're asked to find the probability of not A given not B. In this case, it's really important to go back to the basics. Remember the formula for the conditional probability, and that is that the probability of A given B is equal to the probability of A and B divided by the probability of B. Now, we should probably rewrite this for our specific case. And that would allow us to see that we don't have all the information we need yet. I need the probability of not A and not B and the probability of not B as well. So quickest way to get that information is to draw a Venn diagram, which won't take too long. So starting with the big box for the outside, I'm going to draw a circle for A and a circle for B. And I'm going to write in all the information I know. I know that the probability for the overlap, A and B, is 0.13. So the probability of A on its own and not including B will be 0.35 minus that, so 0.22. And the probability of B on its own without any of A will be 0.45 minus 0.13, which will be 0.32. Now, if I add those together, 0.22 plus 0.13 plus 0.32, that comes to 0.67. That means the exterior bit will be 0.33, and that exterior bit is one of the things that I need the whole thing. So that, in fact, the exterior, the outside, is the probability of not A and not B, and that's equal to 0.33. The probability of not B is 1 minus the probability. Okay, let's move on and look at the next part C. And for part C, we're given extra information about another event C and asked to draw a Venn diagram. I mean, that's not too hard for us. There's a lot of marks going on here, so we should probably take a bit of care. So I'm going to begin by drawing the box around the outside, and then positioning A and B, which I know have an overlap. That's A, and that is B. But I'm also told that C is mutually exclusive. It says here A and C are mutually exclusive. That matters because it means that we can draw C as a separate, as a separate entity over there. That can be C. We're also told that B and C are mutually exclusive. But just here, B and C are statistically independent. That matters because it means that we can use that information to find that area there. So that's what I'm going to do first. The probability of B and C is equal to the probability of B times the probability of C, which gives me 0.45 times 0.2, which is an 18th, I think. No, something like that. I'll work it out. Turns out it's nothing like an 18th. It's 0.09. So I'm going to fill that in, 0.09. Well done, 1 mark. Next, I need to work out the other bits that I can fill in. Well, we know that the intersection A and B is that bit there. So I'll go ahead and fill that in as well. That's 0.13. And we can take that away to get 0.22, which we did previously. So if we do the probability of C minus the 0.09, that gives us 0.11 here. And that means that probability of just B, this central section, is going to be 0.23. That leaves me one section to find, which is the outer section. And I can do that by simply totaling the 4 areas here. No, 5 areas, 1, 2, 3, 4, 5, totaling those and subtracting from 1.